All right, guys. Here's some homework help on 2 of the homework problems. Here's number 9. I'm going to start with that one just because I think it kind of fits nicely. Hopefully you get this done on your own. If not, this will get a little help for you. So you're asked to find a side length x and an angle b down here in the bottom right. So this should sort of make you pause for a minute because there are no right angles, which means you can't use right angle trig initially. You should be in the habit now of recognizing the idea of drawing an altitude. So that's sort of an obvious move, and technically you could draw an altitude this direction or that direction, but this is sort of the obvious one that allows you to now have 2 right triangles, one on the left, one on the right, that you can compare and analyze. The one on the right has 2 variables. You don't know this bottom side, you don't know that angle, so you're kind of stuck on that one. But the one on the left has 2 givens. It's got a side length and an angle. So you could, find this bottom. I'll call that B. You could find that bottom side, and that's an adjacent side. I won't call it B because we need B here. That's an adjacent side relative to a hypotenuse. So hopefully that helps you get started on there. Adjacent and hypotenuse is a cosine ratio. So if you set up a cosine equation from that little angle on the left, that would be the adjacent side, that piece of x, because x is this whole thing, that piece of x divided by 12. A little bit of multiplication. I think that should be around 8.6. I'm going to keep these extra decimal places during my work. Later on, I'll round to the nearest tenth. I'll round to that place. If I do that now, I'll lose precision, so I'm not going to do that yet. So there's, part of x. I found that piece of it. I have to go find this piece in a minute. But again, on this triangle on the right, I don't have enough information, so I'm going to need another side length. I'm going to find that altitude. I'll call that h. And I could do that using opposite over hypotenuse, which would be a sine ratio from that 44-degree angle. And again, I'm going to call that side length h, the height. A little multiplication on that one, and you should get a number that's smaller than 12 as well, which, numerically these should make sense. They're very close together. If you think about this is almost a 45, 45, 90. And a 45, 45, 90, they'll be exactly the same. So they're almost exactly the same. Makes sense. Now I have a length here, so I got choices. I could use, Pythagorean theorem to find this side length down here, which would give me part of this entire length x. I could compare these 2 sides, which again on the other triangle is an opposite over hypotenuse ratio, which I think is what I'll do to find b. Eventually I want to find b either using sine, cosine, or tangent, using some inverse trig. Sine ratio seems to work the best. Opposite side divided by the hypotenuse would give me that angle. So get this as a decimal in your calculator. I think that's around 0.39. Sine inverse that, and you should end up with b right around 23 degrees. Now I'm not going to use this rounded value to find this part of x. Maybe use the exact value in my calculator, but I'm not going to use the rounded value. I think it's easy just to call this something, question mark on there, and do a little Pythagorean theorem to find that missing side length. And I think if you work that out, it ends up being around 19. Now again, that's that piece down here. Got an arrow for that one. And then I also found this one over here. So to find the entire side length x, I just combine those 2, add them together. It's just a multi-step problem. I think it should be around 27.9. Now the other one you have on your paper, you don't have this picture, but this is the theme. You're driving along the road, you look up at a mountain range in the Rockies, and you're like, oh my gosh, how high is that mountain? And all you know is the angle you're looking at is 3 degrees initially. Think about what happens as you get closer to the mountain. You'd have to look, you get really, really close to the mountain, you're looking straight up at it. Your angle's going to increase, so the angle increases up to 13 degrees. This is problem 7 on the homework. And you were driving 60 miles per hour. If you haven't read that yet, take a minute and read through that. If you drove for 8 minutes, 60 miles per hour means 60 miles in 60 minutes. So you're essentially driving 8 miles. So, make a sketch of this. You're driving along here, you've got a right triangle. This represents the height of the mountain. This represents the distance to ride, drive through a tunnel directly underneath the top of the mountain. And a few minutes later, you're further ahead. So that angle of incline, which is from horizontal, is called 3 degrees. a few minutes later, you're closer, which means that angle looking upwards is going to increase. This 3-degree looking up is now increased to 13 degrees. This is a tricky problem. This is going to make you really think. This is going to challenge you. That distance is the only thing you know. You know you traveled 8 miles because 60 miles per hour in 8 minutes give you 8 miles. If I was in class, I'd ask you, how many triangles are in this problem? And of course, you'd realize there's 3. There's this triangle, which is not very helpful because it doesn't have a right angle. There's this triangle, which does have a right angle because we're making that an altitude. And then there's the big triangle. This is going to require a system of equations to set it up. This is kind of putting together systems of equations, which empowers you to do a heck of a lot when you combine it with trig, long-term mathematically. So maybe, put a variable there. Call that height h that you're trying to find. Call that length you don't know down here to the mountain x. And I'll come back in part 2 to show you how to finish that problem off. That should give you enough to set up a system that you can solve with some decimals. Just a system equation with decimals.